Students, so today we're going to talk about our next weldment. I've got parts falling down on me from all over the place. Very, very scary. Helmet's falling all over the place. Get rid of that helmet. Okay, so we're going to talk about our next weldment. Our next weldment is going to be a fillet weld. And for this weldment, we're going to use two 6-inch pieces of inch and a quarter by 1/8-inch metal by 1/8 inch, not the 1/4 inch, but the 1/8 inch. So we're using metal that's a little bit thinner, and we're going to create a fillet weld, commonly referred to as a T-weld, and we're going to set it up as such. And so you're going to take your one piece of metal, you're going to set it right exactly or as close as you can to the center of your flat piece of metal. We're going to tack it here, and then we're going to tack it here also on the back side, and then we're going to run a 2-pass and then a 3-pass on either side. The electrode that we're going to be using today is our 1/8-inch 6011. Is 1/8-inch 6011. The amperage that I have it set for is about 84, 85 amps. Okay, so let's get started welding this up. You can look around in your rod bucket and whatever type of rod stub that you have to weld this up with, to tack this up. I really don't care what you use, as long as you can get a good tack on it. And let me double check my helmet and make sure that it's not left on grind mode. That's about where it needs to be. Always a good idea to double check your helmets and make sure that they are not on an incorrect mode. Somebody's hitting my buzzer wanting in my shop while I'm doing a recording. Well, that's just too bad. Okay, so we want to set this up just as close to the middle as we can get. So we're just going to eyeball it. And we're going to put a little tack on the end. And again, you want to push down, and you want to keep it down because the heat's already causing it to rise a little bit. So push down, try to keep it as close to the center. Don't let it move too much. And that should be a pretty good tack to hold it in place. What you're looking for when you're tacking it is to make sure that there's no gaps in between there, that it's flush. It's flush on both sides, and it's pretty evenly spaced. Pretty close to the same amount of distance on this side and same amount of distance on this side. And now, obviously, I'm not going to take a tape measure and all of that, okay? I'm not going to do that. Now, your 6011, 6010, 6012, these are known as these are a little different than your 7018s. We typically use a stitch or a circle pattern whenever welding with these. With today, we're going to use a stitch pattern, what we call a stitch pattern, or weave pattern. So we're going to establish our arc, and again, when we're doing a 2-pass, our first pass, our electrode is going to be almost straight up and down, about 15 degrees or 13 degrees in direction of travel, and our stitch pass is forward and back, forward and back, forward and back. And I'm over exaggerating just a little bit for the benefit of the camera. All right, obviously I won't be moving back this far. It'll just be just a slight about an 1/8 or a 1/4 of an inch as I'm moving back. Again, with this bead, as I'm pushing forward, I want to watch and make sure that my weld bead, my weld puddle is washing up onto the T portion, the upright portion of my metal, that I'm not just running a bead on the flat portion. I'm going to get my big hands out of the way here so you can see. I want to make sure that my puddle is washing up on the upright section and not just on the flat portion. So that in theory, if I'm only running one pass as such, that should be able to hold it to some extent. Okay? But obviously we're going to run some reinforcement on there a second pass, and we'll talk about that in a minute. But again, our first pass is going to be straight up, almost perpendicular. We want to watch our weld puddle also and make sure that we're not getting our electrode down like this. If you see your weld puddle start to jump up on the upright portion of your weldment, then your electrode is at the wrong angle. So you want to keep it almost perpendicular, and then just kind of back and forth, back and forth, back and forth, back and forth, back and forth as you work the length of this weldment. Right? So that is the first pass on a two-pass weldment, on a two-pass bead. Okay? And again, my amperage is set at about 84, 85, and that should work pretty good. So, let's see what it looks like. Again, let's set ourselves up, get ourselves comfortable, because we're going to be here for a few minutes with this, or a few seconds anyways, pretty close to a minute with this electrode. The tendency is to want to watch the end of the electrode as it goes back and forth, okay? So the tendency is to want to watch that electrode. Try not to do that. Try not to watch where that electrode's going, all right? Because as you do that, all right, you see my hand doing like this. Watch where you left your electrode. So you come back to the same place every time, okay? Watch where you're leaving your puddle. Don't watch where your electrode's going, because then you'll start doing this, and next thing you know, you're way off of your weld bead. Watch where you left your electrode. Okay, my eyes are focused here, okay, and you can't really see because my helmet's in the way. My eyes are focused here, not over here. All right, I'm not watching. All right. Watch where you left your electrode. Watch where you're leaving your puddle. All right, ladies and gentlemen. Let's clean this up a little bit. See what it looks like for Mr. Clark. A lot of instructors start their students with 6010, 6011, because really it's a pretty easy electrode, honestly, to strike an arc with and run a bead with. One of the reasons that I don't is it's a little bit more difficult to lay a bead down with, at least a decent looking bead. It requires a lot more cleaning, uh, not a lot more prep. I mean, 6010, 6011 will weld on just about anything. It's known as a farmer's rod. But if you don't stack them just right, if you don't space them just right, um, they don't look very well. And it's a very hot burning rod too. This weldment is going to heat up very, very much, and it tends to leave quite a bit of slag as well. Okay, there's my first pass. I'll hold it up to the screen for you. Here's my first pass. It's pretty flat. I got a good connection up on the T portion of my weld. So that's what the first pass looks like. So I'm going to take my second pass now, and I'm going to drive it at the top of the toe. Again, I'm right-handed, so I'm going to go from right to left. I'm driving at the top toe of that weld. Again, I'm working at a 45. And again, I'm doing the same stitch motion, back and forth, 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 back and forth. I'll weld up about half of this, about 3/4 of it, so you can kind of see what it looks like whenever you come into the shop. Okay, you want to be careful of some undercuts. All right, I'm going to be watching this weld. If I start seeing some undercut, I may crank the amperage down just a little bit. Typically, I would have you be dunking these about every 3, 4 passes. I'm going to make 5, 6 passes on here without dunking it. So we'll see how it does at about 84, 85 amps. Again, I'm going to run at a 45 at the top toe of that weld. And you'll see that I'm using, apologies to Professor Stott, but I'm tagging my name on it too because I teach it over here at Wasco. But I'm using the Stott Jeremy or the Stott Clark method. I'm putting my electrode on the end. If you watch, I'm putting my electrode on the end of the weldment and pulling it up and establishing my arc and pulling it back and forth. Thank you, Professor Stott, for that insight on how to establish that arc instead of the tap or the strike method. Putting my electrode on the end. Let me start it from over here. Putting my electrode on the end of my weldment, pulling it up, establishing my arc, and then going from there. Apologies to, again, Professor Stott at BC, who showed me how to do that. Very excellent way on these types of weldments of striking an arc. And here we go. Until you get it stuck like that, trying to. And we shall try it again. Again at a 45. And if you're watching where you left your last weld, or you left the puddle, it'll help you stack the diamond so much easier. Again, a very, very hot weld, very hot burning electrode. Not as clean and pretty looking as a 7018. That is why 7018 is typically used for tap welds. 6010, 6011, 6013 are used more for filler welds and things like that. But if you've got something that needs filled, 6010, your 60s will do it very, very well. Okay. A little bit of slag left here on top. Okay. And it is starting to get very, very hot. Very hot. But you can see there what the stacking effect looks like. Okay, and I've got a little bit of slag left over on it there for you. So let me go grab a pair of pliers, and I'm going to dunk it in the dunk tank real quick. Don't go anywhere, ladies and gentlemen. Woo, burning my gloves and everything else. Yeah, so you can see now. Okay, there's what it looks like. A little, still hot. Gaza. Okay. All right. So on the back side, ladies and gentlemen, we're going to do a 3-pass. We're going to do a 3-pass. Our electrode stays the same. We're going to do it at 45 right across here. 45 right across here. I'm going to take a moment and kind of let some of this water dry up because I don't want to pull any water into my weld. That's what creates porosity. Okay, so we're at a 45 right across here. Okay, and again about perpendicular to where I'm putting the electrode, and about 15 degrees direction of travel, back and forth, back and forth, back and forth, back and forth, back and forth. And I'm going to weld this one out completely, and we'll see what it looks like. And I'll have this all cleaned up nice and clean for you, ladies and gentlemen, so you can take a look at it. And I'll put a wire wheel on it, a wire brush, so it looks all nice and good, all right? And again, using the stock Clark method of striking an arc, and here we go. Boy, it's definitely getting hot. Woo, it's definitely getting hot. It is starting to burn hot. It is starting to burn hot, ladies and gentlemen. The weld puddle just starting to run all over the place on me. Sometimes with these, it's a little more difficult to get the slag all cleared out of it. I don't care if you take it out there, take it outside, and put a wire wheel to it. I'm fine with that. That's what we have them for. Okay? We just don't do it inside the booth. Yeah, a lot of undercut on this one. I'm going to crank the amperage down quite a bit. I'm going to crank the amperage down. crank the amperage down because it's really, really getting hot. And that's not a problem. If you see it's getting hot, just crank your amperage down. Work with it that way. Okay, so we're going to run another pass. We're going to run it at a 45 down here at the bottom. Run it at 45 at the bottom toe here. And we're going to run it all the way to the end, all the way to the end there. This slag is very difficult to get off of here. It's important that you get all the slag off so you don't leave any slag inclusion on the weld. Okay, so here we go with the pass, and just like we did with the first one at a 45, but right at the bottom, going on the bottom toe of this weld. This pass is probably the most treacherous because there's a tendency to get slag trapped right in here, the top toe of the weld, and the top piece of metal. So you must be very careful not to get metal, not to get slag trapped inside there. Again, if you need to take it out and hit it with a wire wheel, that's all good. Okay, if you look real close, you can see the difference in cranking down the amperage a little bit, what it's done to my weld. It's cleaned it up quite a bit. Still getting good penetration. The weld's looking nice and flat like it's supposed to. All right, now if I was on a job site and I was worried about this weld passing inspection, I would have this thing out on a wire wheel. I'd have it out cleaned up real good, clean this slag out. Okay, but I'm getting the majority of it with my wire brush. It's looking pretty good. It's looking pretty good with my wire brush. Now my last and final pass is going to be at the top toe of this weld that I just laid down. I'm going to run it right across here, right across the top of the toe of the weld that I just laid. All right, I'm running right across the top of the toe of the weld that I just laid down. Okay, and I'm gonna weld it out for you, ladies and gentlemen. And part of the reason is that weld got hot, and I've got quite a bit of undercut on that. So I'm just going to weld it out so you know what it looks like. And here we go. I got most of it cleaned up for you right there. I'm bumping up against the clock, ladies and gentlemen. So there's your 3-pass. There's your 2-pass. Got most of the slide cleaned up off of it. Okay, a little bit of undercut right there. I might even crank my amperage down just a little bit more, or I would be dunking it in the dunk tank, that's for sure. So, ladies and gentlemen, that's your next weldment. Remember this. It's on the 1/8 inch, not the 1/4 inch. We're using a little bit thinner metal. I'm going to be looking for things like, are you able to control the undercut? I don't want to see a bunch of undercuts. Okay, I don't want to see a bunch of undercut. I don't want to see a bunch of welds that are running all over the place. Control the weld. You look at your amperage. Follow your amperage. If you're running too hot, crank it down. Crank it down. Okay? Don't be afraid to play with your amperage a little bit. Don't be afraid to play with your travel speed. You notice I was traveling just a little bit faster with this one because it was heating up. Don't leave it in the water tank so long that it comes back soaking wet. Dunk it, just enough to cool it down, and then come back and start welding on it again. All right, ladies and gentlemen, that's it for today. If you got any questions, I'll see you in the booth. This is Clark, and I'm out.